This program contains experiments which are performed by professionals. These tests are dangerous and may involve the use of hazardous materials. They should not be performed or imitated under any circumstances. The famous plasma module. It's made up of two thin plates of glass stuck to one another. It's here where, thanks to plasma, pictures are created. But to understand how, it's time to do some shattering. It all starts with an incoming video signal. For example, through a cable. The signal is sent to the video card, where it's decoded, and to the electronic circuits controlling the appearance of pictures in the plasma module. The module's two glass plates are covered with transparent electrodes. And in order to transform these electrical impulses into pictures made of colored light, the plasma module needs plasma. The transformation happens between the electrodes, in the pixels. They're tiny cavities engraved on the rear glass plate and trapped under the front glass plate. Each pixel constitutes 1 point on the picture being displayed. Each pixel is divided into 3 subpixels. The bottoms of the subpixels are coated with phosphor, a substance that gives off light when excited by ultraviolet rays. When that happens, the first subpixel gives off red light, the second gives off green light, and the third, blue light. By combining these 3 colors, each pixel can produce 549 million different colors. Each subpixel is filled with a mixture of gas, xenon and neon. When an electrical impulse of about 300 volts rushes through a subpixel on its way to the electrodes, electrons from the gas mixture are violently torn off and suddenly float freely. It's no longer gas, it's now plasma. As soon as the discharge ends, the freed electrons immediately return to their places, and the plasma once again becomes gas. As they return to their places, the electrons release their surplus energy in the form of ultraviolet rays. It's these rays that excite the subpixel, which gives off light that combines with the light given off by the 2 other subpixels, and together, they light up the pixel. Every second, the plasma screen sends more than 2 billion electrical impulses into the subpixels in order to turn the gas there into plasma. The sole purpose being the ultraviolet emissions given off once the plasma returns to its gas state. All that so pictures can appear pixel by pixel on the screen.